Welcome everybody to today's FDTD Goes Applications webinar. Today we're glad to have Doug Wesley from the AWU in Anchorage, Alaska join us, and he'll be leading a presentation titled Applications of GOES 17 Data for Fog Forecasting in the Cook Inlet region of Anchorage, Alaska. Go on to the next slide. And just to call for volunteers, if you have a webinar topic and you'd like to present it, please just contact either myself, Dan Bicus, or Scott Lindstrom, and we can schedule you to give one of these webinars for the future. Also a reminder, all of these are recorded and placed on the visit web pages at the URL that's shown here. Next slide. So just to go over some protocol, Doug will have approximately 20 minutes to speak, and you can either send the questions via the GoToChat or preferably during the Q&A period over the phone. Once Doug is done presenting, we'll take questions over the phone. We'll be done by 19Z, and just please remember, do not press hold, and also mute your phone when you're not speaking. So at this point, I will turn it over to Doug.
Okay, hello everybody from the Aviation Weather Unit in Anchorage. Today I'm going to be talking about some applications of GOES 17 data for fog forecasting locally and across Alaska. This is a case from late February this year, about 3 weeks ago, and I think the benefit is to get this stuff out quickly so people can see it. Maybe scientific review of it is not rigorous at this point, but the point is to get it out there because these tools are operationally available to forecasters. So, and I'd also like to point out that fog is one of several applications that have been noted locally of GOES 17. Volcanic ash is one, mountain waves is another, but a numerous list have already been compiled here where the GOES 17 coverage, both spatially and temporally, is the best we've ever had here in Alaska. So, okay, let's get on to the caselet. This is a case from 26 February of 2019. This image shows the GFS analyzed 700 heights over Alaska. You can ignore the bright white boundary here. I'm not quite sure where that came from, but that doesn't match up to any boundary that I'm aware of. But anyway, we were under a rare quiet period here in Alaska where we had a large ridge that was dominating our area for over a week during February. You can see the bearing is very active at this time, but in between there's southerly flow, deep southerly flow, and we're close enough to the ridge that it was still quiet here in Anchorage, which is right about at the location of the cursor here. I don't know, Dan, can they see the cursor? Can you see the cursor there?
Yeah, I saw it.
Okay. Now, I'm kind of seeing it on and off, so we'll just have to bear with me. But anyway, the forecast rule of thumb here is when the ridge moves east of you, the flow is becoming more southerly at all levels, albeit weak at low levels. But this is a favorite time for fog formation in the Cook Inlet, which is shown here, and then Turnagain Arm is off to the right, and then the Knik Arm is off to the northeast. So to begin with, the forecasters were alerted to this increased southerly flow in the lowest 10,000 feet or so. Okay, now this is the Anchorage sounding at 12Z on the 26th in the morning. So this is about 3 a.m. That morning, and first of all, I'd like to point out that this wasn't QC'd at the surface. Sometimes that happens with things going on over the forecast office, but this warm air is fictitious. The sounding actually ends about right here. But you can see that strong inversion was present over the Anchorage area, and 12 hours later, not much has changed. We've got temperatures in the -6, -7 range at the surface, and very dry layers through the atmosphere. You can also see this area of near saturation at the surface, which is real and is an indicator of the potential for local fog formation. So we didn't have much change in that 12-hour period in the synoptic setting. So our forecasts, this is a aviation weather unit forecast for flight category, graphical forecast for our entire FIR, or the area we're responsible for, and it breaks down the IFR to MVFR categories, the MVFR shown in blue and the IFR shown in red. And you see all the action is out on the Bering and on the West Coast, where it was most of the winter. And you can see that that's high and dry, again, VFR conditions over the Anchorage area and surrounding areas, and going the MVFR down the inlet a ways. I should point out that one of the criteria for including a AirMet or an AirMet for IFR or MVFR conditions is it has to cover at least 3,000 square miles, I believe it is, which in this case it didn't. You'll see that the fog coverage was much less than that. So the forecaster is kind of faced with a dilemma. Does he or she put the flight category into this flying weather chart, even though it's much less than 3,000 square miles? The catch is that this is an active aviation hub. It's the most active, obviously, for us. So you want to be proactive and you want to hit the impact decision support with your forecast, but technically you're not required to do that for such a large, when we're covering such a large area with our area forecast. So that's a quandary that the forecaster faced that day. And the written area forecast, we still do these up here, and the zone is shown. I'll see if I can get the cursor to go. It's outlined in that area. That's about the size of the zone. So it's about 250 miles north-south and 200 miles east-west. And at 13Z, the fog wasn't perceived as a threat. We had some stratus in the lower south area, south of Merrill Pass to Seward, some broken 030, top 050. Elsewhere, sky clear was in the forecast, and the same with the outlook. So at 15Z, an amendment was issued, which included the previously mentioned mountain obscuration, but it mentioned an isolated fog threat to visibility below 3 miles and ceilings below 500 feet from Birchwood to Anchorage. So it's up in the Kinnick Arm and to the point of its juncture with the Cook Inlet. And that was forecasted until 20Z at that point. And then the noon issuance, you'll see a little later that we had the fog at this time. The forecaster put in this isolated threat below 500 with below 3 miles in fog for the vicinity of Cook Inlet. So the threat sort of enlarged itself as we got these satellite and surface obs in. We'll go to the surface obs now. This is the ASOS at Anchorage, and one can see that by 14Z, we had a quarter mile in freezing fog, 1403Z, 15Z, same, back and forth for a while, and then from 16 to about 21Z, visibility is down below a quarter mile with ground fog at the surface being reported. So hence the update at 15Z in the forecast, where we had a couple of the obs here reporting the fog by 14Z or so, then the amendment was issued at 15Z. And then up the road a ways to the northeast along the Kinnick Arm, about 10 miles is Birchwood Airport, and we can see that there was observed fog from about 15Z off and on through about 21Z. So a little bit less fog was reported. Visibility is not going down as far. I think I see a half mile in here to the Birchwood Airport. So we're going to go to the satellite data and look at the GO-17 for this. You'll bear with me just a little bit. Let's see if I can get this set up. Yeah. So can you see a satellite image there now?
Yeah.
Okay. Okay, this is a 4-panel showing the day fog GO-17 product. So it's a 3.9 minus 10.3 micron imagery. That's in the upper left. In the upper right is the same, except the color table is in black and white, and it's been altered for contrast. On the lower left is the day snow fog RGB, and the lower right is the day cloud phase distinction RGB from the GO-17. And I'll loop through this, and remember we're looking at this area here. This is right about when the sun is coming up at this time, maybe an hour after sunrise, and so that's where the loop starts. So let's go through this slowly. Hopefully you'll see most, if not all, of the frames. So by 1940Z, we're seeing this fog signature. We're seeing a lot of lower cloud and deeper cloud on the west side of the image, some stratus down in here, and also in the Gulf. But we see this curious stationary but enlarging area on the day fog signature here. And we'll loop through that. It maximizes at about 20Z and then dissipates to about 23Z. And you can see more fog down along the Turnagain Arm and to the south of Anchorage at this point. So you can also see in the black and white imagery that there's a nice contrast. You can see that this did extend up into the Connect quite a ways for a couple hours there, as we saw in the Birchwood observations. You can also, see the fog in the day snow fog RGB. This red color is indicating clear skies and snow cover, and you can see the complex terrain around it. But this sort of purplish color shows the fog and stratus down here, and then fog over the Anchorage vicinity, and then shrinking down in time as the afternoon progressed. And in the day cloud phase distinction, you can imagine you can see some contrast in this Turnagain Arm area, but it's a little bit more difficult to pick up in that region. Next, I'll go on out to 23Z on the 26th, and we can see that the signature at that point is up in here. And we'll go to the next image has another PowerPoint animation. I'll try to start that. And this is the same loop, except it has the METARs overlaid under the imagery. So this gives you another perspective. This is the Anchorage area observation here from ASOS. This is Kenai. If I can get the cursor to light up here again. Let's see. There we go. That's Kenai, and this is Homer. And the Birchwood area is up in here, and this is Palmer Bob's up in here. So at this point at 19Z, we've got fog being reported, as you saw in the observations at Anchorage, and we've got fog being reported at Kenai, and just stratus being reported at Homer. So I'll loop through these. You can see the fog goes away at Kenai shortly by 20Z, and sticks around at the Anchorage area up in here through 21Z, and then on, I believe, through 22Z, and then at 23, it's still there, being reported in Anchorage, right on the edge, even though they're on the downturn in terms of the fog extent at this time, and then finally disappears by 0Z, and at this time. Again, most of this stuff is stratus down here in the Gulf. There is some fog, even though likely some fog in this region, although part of this is stratus signature. There are no observations where the fog is likely occurring, and this is deeper cloud off to the west. So, we've never had this type of resolution in our imagery. We would have liked to have seen a further west location for GOES 17, but this is certainly improvement over GOES 15, and the spatial and temporal resolution, along with the ABI imagery, is just, we've come a long ways in terms of what we can detect using the satellite data with the GOES 17 data. And while I'm thinking of it, I'll mention this. The JPO's polar imagery, it is available, and it is very highly resolved data, and the GOES or the NOAA 20 imagery has improved the resolution, but there is still the latency issue, which limits forecasting capabilities. We won't talk about the POS data, but I did want to mention that it is highly resolved data. Also, it's just temporal resolution is lacking for that most of the time. So we'll go to just a zoomed. Let's see. Start this just briefly. This is a Cook Inlet zone here. This is a zoomed area. I hope you can see the geographical boundaries. This is the Turnagain Arm. This is Knik. And this starts at 17Z, and this is the day fog product here, the difference imagery from GOES 17. And as the sun rises, that reverses color, but this is what you saw earlier. This is just zoomed in, and you can see the extent of the resolution here. That you can see the pixel sizes here, but just having this is just phenomenal for us. In terms of detecting fog and other phenomena that are relevant to aviation forecasting. So let's go after the fact. Let me just get this slideshow going here. Oh no, I didn't want to do that. Good. There we go. So after work, I left and I headed south from the Anchorage forecast office, and this is about 0030Z or so on the 27th. So this is a view of the upper portion of the Turnagain Arm when it comes out of Cook Inlet over here, and you can see the fog layer. Again, this was after the fog had dissipated to some degree, but you can see the fog layer here, and these are the Kenai Mountains down here. This is looking south-southeast. So did it matter? That's the question. And the impacts, in general, the operations at one of the busiest international airports at TED, at the Anchorage Airport, is important. This case, the impacts were fairly minor on large aircraft. There were up to 30-minute delays in the Anchorage approach controls operations. These large aircraft can land and take off down to 600 feet horizontal visibility, I believe. So their criteria, they are rated to continue to operate. We did have up to 30-minute delays in the approach controls operation, particularly with the smaller aircraft. I want to emphasize the fog onset and dissipation is very difficult to forecast in several active aviation areas of Alaska. And that's really the point of this presentation, is that you may have an idea that the fog, there might be a chance the fog can start tonight on a quiet night or maybe tomorrow night, but really detecting when the onset and dissipation occurs is highly dependent on the satellite data. So our ability to detect that onset and dissipation has been enhanced extensively by the GOES 17 data. Oh, let's see. And just a further summary, the GOES 17 data represents a major improvement of fog detection in Alaska and aviation impacts of the fog in temporal and spatial resolution and in the advanced baseline imagery derived applications. and these are my acknowledgments. So I'll turn it back to Dan at this point.
Thanks, Doug. At this point, we'll take any questions or comments for Doug.
Hey, Doug, this is Don. Hey, I'm just curious, when were you able to first detect the fog in the satellite imagery?
That would have been before sunrise in the fog product, the night fog difference image, and I believe that was around 14 to 15Z. So it was right about the same time that the ASOS began reporting it at Anchorage.
Okay, that's pretty impressive then. I mean, a small amount of really super shallow fog, and it was detected relatively quickly. Is there any way to get an idea of like how much faster the imagery was able to do compared to previously? Is there any possibility in doing that?
Yeah, we could. That will depend. I'll have to look back at some old GOES 15 cases. That would be interesting to compare that to what we had before. I think that'd be a good thing to look at, and I'll try to find time to do that in the near future.
Okay, thanks. Good presentation.
Thanks.
Hey, Doug, this is Ed. How's it going?
Hi, Ed.
Hey, this is actually more of a her question. Have you found the Her Alaska domain to be of any use in the? I know we have fog and low clouds that we have as an output in that forecast.
Yes, I didn't look at it for this case, but I can tell you just from experience at the forecast desk that it is very useful, especially these larger areas of stratus. Whether it would come up with, I have seen cases from this past winter where it did pick up on a fairly low, small area of fog, maybe 10 to 20 miles across for the Cook Inlet, but I didn't archive that for this case. That's another thing I could look at. This case happened just 3 weeks ago.
Yeah.
But we use the Her Alaska for flight categories all the time here, and the resolution is pretty impressive on these stratus fog cases for flight category.
Okay, yeah, that's good to know. Hey, good presentation. I'm wondering, how do these small aircraft, how do they get information? Do they get stuff in the cockpit or what? Do you know?
Well, I mean, that's the small aircraft is general aviation. We get phone calls for updates. They get their information from our website, but they have a number of private forecasting groups that I can't speak for, and information on the internet is my impression. Some of them are proactive and call us frequently, and they ask us, hey, when's this fog going to dissipate? These are mostly people that are grounded and that are waiting to fly. They want to get updated on when we expect the fog to dissipate. And we get those kind of calls all the time. There's probably a portion of the general aviation crowd that looks elsewhere for their weather information. I can't really speak for what happens there, but this is with our long nights in the winter, this happens all the time. And these fog outbreaks can happen for days at a time here, with a little bit of a diurnal variation. And our cold season here, the diurnal variation can be very small in these events.
All right, thanks, Doug.
Sure.
Yeah, hey Doug, it's Brian. Question about the GOES 17 anomaly. Have you seen any impacts as you're looking for fog in the early morning hours?
Not that I've heard. We've probably had less fog than what we would have expected since the satellite became operational. Well, we got the test data back in November, I think. We've had a number of fog events, but probably less than the average. But like this one, we had some significant events. I haven't heard of any impacts. I mean, typically, the forecasters look for a number of, they're used to looking at alternate sources, like maybe GOES 15 or some polar data to look at it. And it's possible that there have been times when they were impacted, but I didn't hear about it. But it hasn't really come up. I think these are outages that are a few hours at a time. Is that correct?
Right. Yeah, it's mainly with the IR imagery, and
yeah,
it's toward the end of the overnight period. So that was one of the concerns, was that it would affect the fog detection and the use for fog. But it's only on certain days and at certain times. So
yeah, I mean, we get into weather regimes here this time of year and back in the late winter that are weeks long, where the fog isn't an issue. So I think there will be impacts. We just haven't seen them sync up like that yet. So
right, and the visible would still be good. So in terms of high temporal frequency and reduced latency in getting the imagery, that probably helps with the onset and the dissipation of fog at certain of the locations. So
it's
still a lot of
been a
benefits.
tremendous help, tremendous advantage for this to get this data in here.
All right, great. Thanks again.
All right.
All right, any other questions for Doug? Okay, before we end this call, I'll just, at this point, take any questions in general on GOES. Does anybody have any questions in general on GOES? Okay, if not, well, we want to thank Doug for an excellent presentation, and everybody have a great day.